So good day everyone. I'm Juvilia Naspaliarco, the one of the presenter of precipitation. So we're going to present precipitation, its formation, forms, in Philippine setting, types, and artificially induced. So table of contents. The number one is the introduction. The two is formation. Three is forms in Philippine setting. Four is the types of precipitation. And the five is the artificially induced. So what is precipitation? So precipitation is water released from clouds in the form of rain, freezing rain, sleet, snow, or hail. It is the primary connection in the water cycle that provides for the delivery of atmospheric water to the earth. Most precipitation fall as rain. So I will expand the precipitation. So the falling of water from the sky in various form is known as precipitation. They all form by clouds in the troposphere, which are around 8 to 16 kilometer or 4 to 11 miles above the ground. Precipitation happens when any form of water particle falls from the upper atmosphere to the Earth's surface. Frictional drag and gravity induce the drop to the ground. When a particle falls from the cloud, it creates a turbulent wake behind it, promoting faster and more frequent drops. Depending on the atmospheric conditions, the crystallized ice may reach the ground as ice pellets or snow, or it may melt and convert into raindrops before reaching the Earth's surface. The example of precipitation like rain, snow, sleet, freezing rain, hail, snow grains, and diamond dust are all examples of diverse type of precipitation. There are several types of water that fall from the frozen clouds in the sky. So the process. So condensation of water vapor in the air mass causes precipitation due to the adiabatic cooling. The rising air mass containing a significant number of water vapors becomes saturated. Condensation of water vapor causes clouds to develop. In every cloud, there are updraft and downdraft. The updraft determine the growth and height. The stronger the updraft, the taller the cloud. As the liquid water accumulates, the updraft weakens and the downdraft strengthens. Thereafter, precipitation results. While all clouds contain water, only some generate precipitation. Precipitated moisture from clouds sometimes evaporate before reaching the Earth's surface. Precipitation happens when cloud droplets or ice crystal grow large enough to overcome atmospheric updraft. It, it signifies that processes are at work in a cloud that produces rain. So this mechanism can be explained by two processes. So it has two processes. And the first process is called Bergeron process. The cloud contains ice crystal and super cooled water droplets. When an ice crystal collides with super cooled water, it freezes the water. This method uses two properties of water. So the first property is a cloud water droplets do not freeze at 0 degrees Celsius, but remain liquid until negative 40 degrees Celsius, termed as supercooled water if disturbed. Supercooled water will freeze. It needs nuclei to freeze on, but freezing nuclei are rare in the atmosphere. Hence, with an increase in temperature, some water droplets will turn into ice, encouraging the formation of all ice cloud. A single ice crystal is added to a supercooled water droplet cloud. The second property is over ice crystals, the saturation vapor pressure is lower than over water. Between water and ice crystals, a vapor pressure gradient is created, ice crystals are formed at the expense of supercooled water. When these ice crystals get large enough, they begin to tumble out of the cloud. These ice crystals melt and fall as rain before reaching the ground. So the second process is called collision or coalescence process. This method is suited to clouds whose base does not exceed the freezing point. Warm clouds are these. These clouds have several various sized cloud droplets. Large drop expand at the expense of smaller ones, so they crush the smaller droplets and form part of it. Updrafts and downdrafts repeatedly lift and lower cloud droplet in a huge cloud, so this drop grows swiftly. Raindrops must have a diameter at least 100. So cloud droplets collide to generate the size of a drizzle droplet. More collision produce larger drops and rain. Small droplets of uniform size may be present in clouds that do not produce precipitation. A condition like this could lead to colloidal stability in the cloud. Because of the small sizes of the droplets, a collision may not occur, and these cloud droplets can fall slowly and uniformly without colliding. As a result, any clouds that lack the required size of cloud droplet may fail to produce precipitation. So next slide. So next slide, please. So let's talk about formation. So formation. The clouds floating overhead contains water vapor and cloud droplets, which are small drops of condensed water. These droplets are way too small to fall as precipitation, but they are large enough to form visible clouds. Water is continually evaporating and condensing in the sky. If you look at the cloud, you can see some parts disappearing, or some parts are evaporating, while other parts are growing or condensation. Most of the condensed water in the clouds does not fall as precipitation because its speed is not large enough to overcome updraft which support the cloud. So for precipitation to happen, first tiny water droplets must condense in even tinier dust, salt, or smoke particles, which act as a nucleus. Water droplets may grow as a result of additional condensation of water vapor when the particles collide. If enough collision occur to produce a condensation of water with a fall velocity which exceeds the cloud updraft speed, then it will fall out of the cloud as precipitation. This is not a trivial task since millions of cloud droplets are required to produce a raindrop. A more efficient mechanism known as the Bergeron-Fedysen process for producing precipitation-sized drop is through a process which leads to the rapid growth of ice crystal at the expense of the water vapor present in a cloud. These crystals may fall as snow or melt and fall as rain. So next slide. So the water cycle. So what is the water cycle? So the water cycle is the path that all water follow as it moves around Earth in different states. Liquid water is found in oceans, rivers, lakes, and even underground. Solid ice is found in glaciers, snow, and at the north and south poles. Water vapor, a gas, is found in Earth's atmosphere. So water can be found all over Earth in the ocean, on land, and in the atmosphere. The water cycle is the path that all water follows as it moves around our planet. So where is Earth's water? So 96.5% is in the ocean, and the 1.7% of the water is in lakes, rivers, streams, and soil, and the 1.7% is in polar caps, glaciers, and permanent snow, and the 0.01% is water vapor in Earth's atmosphere. So you can find water in all three states of matter, which is the solid, liquid, and gas. So the water cycle. So when the sun heats causes glacier and snow to melt into liquid water, this water goes into oceans, lakes, and streams. Water from melting snow and ice also goes into the soil. There, it supplies water for plants and the groundwater that we drink. Snow falling on a glacier during winter months usually replaces any water that melts away in the summer. However, due to Earth's overall warming, most glaciers today are losing more ice than they regain, causing them to shrink over time. How does water get into the atmosphere? So there are two types. There are two main ways that this happens. So when the heat from the sun causes water to evaporate from oceans, lakes, and streams, evaporation occurs when liquid water on Earth surface turn into water vapor in an atmosphere. So and the second is water from plants and trees also enters the atmosphere. So this is called transpiration. So warm water vaporizes up through Earth's atmosphere. As the water vaporizes higher and higher, the cool air of the atmosphere causes the vapor to turn back into liquid, so creating clouds. So it creates clouds. So this process is called condensation. When a cloud becomes full of liquid water, it falls from the sky as rain or snow, also known as precipitation. So this is our discussion. Rain and snow then fill lakes and streams, and the process starts all over again. So it just starts all over again. So the next slide. So forms in Philippine setting. So forms in Philippines setting. In the Philippines, an archipelago of thousands of islands, the climate is generally tropical maritime, with a relatively cool season from December to February, when the north east trade wind prevail, and hot, humid, and rainy seasons from May to November, when the southwest monsoon prevails. Between March and May, before the arrival of the summer monsoon, the temperature increases and reaches the highest level of the year, especially in the center north and in the interior of the larger island. Hence, in general, the coolest month or the least hot is January, while the warmest is May. In Luzon, in north of Luzon, cool air masses can sometimes arrive from December to March, so that at night the temperature can drop to around 12 to 15 degrees Celsius or 54 or 54 to 59 Fahrenheit. On the southernmost island close to the equator, the temperature are more stable and remain high all year round. The least rainy period varies depending on area, and as weekly pass, it advances proceeding from north to south in Legazpi or Luzon Island. Rainfall drops below 200 mm to 8 inches per month from March to May, while in Borongan, Samar Island, this happens from July to September. So Legazpi. Here is the average precipitation in Legazpi located in the southeast of the island of Luzon. So you can see here in the table from March from the month of January to December. So next. So Legazpi. Here is the average precipitation in Legazpi located in the southeast of island of Luzon. Um, you can see here a table from month of January to December. In the rest of the Philippines, the climate can be defined as tropical since it is possible to identify a dry season, which usually runs from February to April. But but in the most sheltered areas, the rains are rare even in December and January. The dry seasons is more evident in the western part, blue area, while it's less evident but still present in the central part. In contrast, the summer monsoon is generally more intense in the western part. In this area, the biggest cities of the Philippines are found starting from the capital of Manila. The southern islands, Batanes and Babuyan, are located far to the north, almost at the tropic in winter. They are affected by cool air masses from the Asia continent. So the weather is pretty cool from December to February, with average height around 24 to 25 degrees Celsius or 75 to 77 Fahrenheit. Here is the average precipitation in Basco. You can see here in the table from the month of January to the December. So the next one will present the types of precipitation.
So good day everyone. I am Ralph Ramirez and I'll be the one continuing our report formation forms types and artificially induced, which is started by Miss Palyarco, and I'll be the one discussing the types and artificial induced of precipitation. So let's start with types of precipitation. The first type is the rain. Most commonly observed drops larger than drizzle with a 0.02 inch or 0.5 millimeter or more are considered rain. However, smaller drops are also considered raindrops if, in contrast to drizzle, they are widely separated. So, as water vapor gathers and condenses, turning back to liquid in the clouds, the drops become too heavy in the air, and gravity pulls the water drops down in different types. And the most common one, especially here in our country, is rain. So the second one is drizzle. Fairly uniform precipitation composed exclusively of fine drops very close together. Drizzle appears to float while following air currents, but unlike fog droplets, it falls to the ground. Quiet often fog and drizzle occur together. It's observable naman din ang pagkakaiba ng rain at drizzle. Unlike to rain, drizzle have fine droplets but close together. This also reduces our visibility. So medyo delikado din siya sa mag-travel with drizzle since mahirap or worse, di mo makikita ang dinadaanan mo. So number 3 is ice pellets or sleet. Precipitation of transparent or translucent pellets of ice which are round or irregular hard grains of ice consisting of frozen raindrops or largely melted than frozen snowflakes. So sleet happens only on cold countries but not that ice cap climate countries, since sleet occurs when snowflakes only partially melt when they fall through a shallow layer of warm air. So snow siya at the first place, tapos pagkahulog niya is partially siya mamelt. Kasi pag na-melt siya, ang tuluyan due to the temperature, magiging water na siya, then that is what called rain or ulan na siya. The next one is hail. Precipitation in the form of small balls or other pieces of ice falling separately or frozen together in irregular lumps, associated with thunderstorms. Individual hailstones are 1/4 inch or 5 millimeter or greater in diameter. Hail sizes of 1 inch or 2.5 centimeter or more are indicative of severe thunderstorms. So kapag dito sa atin is, pag nagbagyo is malakas na ulan at hangin, sa ibang bansa naman is, they are experiencing this what we call hailstorm. The worst thing about that is pag tumama na sa iyo ay masakit talaga. Also, as what I have seen on several videos on countries experiencing hailstorm, is pag tumama sa mga glass or salamin ng sasakyan is mababasag talaga. Kasi ice na siya eh. What supposed to be liquid is nagiging frozen siya due to very cold weather or temperature. Number 5 is small hail, small pellets. Precipitation of white or packed grains of ice that are round or sometimes conical. Diameters are less than 1/4 inch or 5 millimeter. So for the small hail it is hail but smaller version. Number 6 is snow. precipitation of snow crystals that are mostly branched and in the form of six-pointed stars. So as the water goes up and condenses, as we recall the process of condensation, for the vapor to cool, then condenses back to the liquid in the sky and it forms as an ice crystal. Since it is so cold up there, then as it falls down, it becomes to a form of rain as it warms up due to hot temperature. Just like in our country, that's why compared to other country, specifically to cold countries, they experience snow as their temperature out there is low. So the snow formed above the sky falls down as snow pa rin since it maintains its form due to cold temperature. The snow or the ice crystal doesn't melt down. Kasi what I have said earlier, snow or crystal ice talaga siya in the first place. Tapos pag nahulog siya, kung cold ang temperature is ma-maintain niya yung form niya. Tapos pag medyo warm like in our country, we have a warm temperature na melt yung ice tapos mag-form siya into water. Tapos yun na siya ang rain. Tapos kung partially melt lang siya that is what we call sleet. So number 7 is snow grains. Precipitation of very small white and opaque grains of ice. Basically, this is frozen drizzle. It is understandable naman by its definition na the same lang siya, drizzle, but for the case of snow grains is dili siya a liquid or water, it is an ice. So number 8 is ice crystals. Generally occurring in very cold regions, they are falling crystals of ice in the form of needles, columns, or plates, also called diamond dust. Ice crystals appear like fog with individual water particles forming directly as ice. The shape of the individual ice crystals causes the light pillar optical effect above the light source. So for the ice crystal is konti lang talaga siya. Siguro kung makikita mo in person is maganda siya tingnan. Unlike sa other precipitation na maramihan yung pag-precipitate. So now let's discuss the artificially induced precipitation. Artificially induced, it's a practice of artificially inducing or increasing precipitation through clouds by adding external agents. The foreign particles which are drenched over these clouds can be dry ice or solid carbon dioxide, silver iodide, salt powder, etc. This process is known as cloud seeding. This stimulation is done by aeroplanes or rockets, and then finally rain on. So for the artificially induced, from the word itself, artificial, it will not follow the natural process of hydrologic cycles. In this case, there are man-made artificial operations involved, which is there is an addition of chemical in order for the precipitation to happen. So how it is done? First is agitation. The first stage includes the use of chemicals to stimulate the air mass upwind of target area to rise and form clouds. These chemicals absorb the water vapor and helps in the process of condensation. Chemicals like calcium oxide, compound of urea, and ammonium nitrate or chloride calcium carbonate. Next one is building up stage. In the second stage, the mass of the cloud is built up by urea, dry ice, kitchen salt, or etc. to increase the density of the clouds. So the next one is seeding. The final stage of pursuing the artificial rain, super cool chemicals or dry ice or iodide are bombarded with a pressurized canister onto the base of the clouds to build the beads of water and make them fall as rain. Is cloud seeding effective? So forecasters and scientists have estimated that cloud seeding operations can enhance rainfall by as much as 30 to 35% in a clear atmosphere and by up to 10 to 15% in a turbid atmosphere. So hindi siya talaga fully effective. There are instances or chances na hindi siya mag-work. And it is risky to use cloud seeding as a solution if we suffer a water crisis, since cloud seeding costs a lot of money and there are possibility na hindi siya mag-work. or the target area where they planned for the cloud to precipitate doesn't match as what they planned. So it is a huge waste of money if this operation didn't work way back 2010 nga when we suffer El Nino, or our government operates cloud seeding to solve the crisis of drought. Many operations but only 20% works. So pag nakatulong man ang cloud seeding, that time is napakaliit lang na porsyento. It doesn't fully solve the problem. So in conclusion is, hindi siya fully effective ang cloud seeding. It may be effective or sometimes it may be a failure. So that's the end of our presentation. Thank you for listening.